come tonight. I want to make this as casual as possible. If you have questions at any time, raise your hand. I'll try to save some time at the end, but definitely feel free to just stop me at any time, and we'll kind of take this in the direction that you guys want to go with it. So let me pull up a couple slides. So this is going to be about running Java, Play, and Scala on the cloud with Heroku. I'm really only going to try to spend a little bit of time in the slides and try to spend a lot of time in code and building some applications, deploying them on the cloud. So hopefully that's okay. Hopefully you guys, if you want to see slides, I can show you slides instead, but more fun for me to write code. So hopefully that's okay. So let's see. Let's jump in. So I started thinking about, this is a really ugly slide that I just was starting on today. I started thinking about what are some of the emerging trends in our world? How do they relate to the cloud? And I think there's kind of 4 major trends right now that are changing a lot of how we build applications, how we deploy applications. I'm not going to go into details on these. I think I'm going to try to highlight these as I talk tonight. But I think the point is that there's a bunch of things changing in our world right now. And the cloud is really the center of a lot of what's changing. The reason for that is that the cloud allows us to be able to build much more rapidly in infrastructure and systems. So that's why I think it's interesting to be here talking to Java developers about the cloud, because our world is not like it's been for the last 10 years anymore. We've got all these new technologies coming around. A lot of things are changing. We're not just writing like simple CRUD applications talking to a database anymore. We're doing things like Hadoop and Cassandra. We're doing MongoDB, and we're doing real-time in our web applications, and we're doing social networking, figuring out how to engage our customers in different ways through social channels, and that's definitely impacting how we build applications. So there's a lot changing, I think, for us right now. So I think it's an exciting time. There's lots of job opportunities, obviously, amongst this change and all this flux that's happening. But I'm going to be talking tonight about Heroku and about how we deploy applications on the cloud. So kind of specifically around, we've got this system in the cloud. We want to run applications on the system. So how do we do that? So a little bit about Heroku. So Heroku is a cloud application platform. It really is 3 major pieces. It's Polyglot, so it supports a lot of different languages. We started with Ruby, so most people that know about Heroku probably know about it from the Ruby days, and that's all that Heroku did. Pretty recently, we announced support for Java and Scala, and also Node.js and Python, and a bunch of other languages. Then it's also a platform as a service. So this is the ability to take your application and run it on the cloud. And then there's the cloud components. And this is where we can extend beyond just this base layer that is just our application to additional services, things like MongoDB as a service, and things like Memcache as a service, and those sorts of things. So I'm going to talk a lot more about this throughout the night. But one thing to point out, we do have over 1 million applications now running on Heroku. So there's a lot of different types of applications, everything from like Best Buy has a marketing site that runs on Heroku, to startups that are running on Heroku, and now we're getting enterprises. Now that we've got a Java support, now running their enterprise applications on Heroku as well. So lots of different applications on Heroku. Yeah, go ahead.
How many of those applications are for pay?
So I'll talk more about the pricing model in a little bit, but the basic pay structure of Heroku is that you can run basically one node for free on Heroku. So of course, some percentage of this 1 million applications is only running one node, and then whenever you scale beyond one node, that's when you actually pay for something. So I don't know the actual percentage numbers of how that 1 million plus breaks down into people that are running on more than one node and people that are running just on one node. I'm not sure of that number, but yeah, so these are just applications. So because each application has, 1 or more nodes, we have more than 1 million essentially nodes running on Heroku. And I'll talk more about the details of what our nodes are, all that kind of stuff in a little bit. Any other questions before we go? Okay, so I think there's 5 major parts of Heroku that I'm going to really weave into some demos not going to go into a lot of detail in the slides, but just point them out. So instant deployment, being able to instantly deploy our application on the cloud. There's HTTP routing and load balancing, so being able to handle HTTP requests, load balance those HTTP requests. There's the elastic polyglot runtime, being able to scale up and down instantly. Thank you. And then there's so elastic polyglot runtime is supporting multiple languages, of course. And then management logging, so being able to manage the full system, being able to get logging information out of the system, those sorts of things. The APIs that you can call to manage everything that's happening on Heroku. And then the last one, the component as a service ecosystem. So this is the cloud components. We call them Heroku add-ons, but really they're just ways to extend the basics. So with that, I want to jump into a demo, which will kind of walk through all 5 of these, but show it in actual live running code and examples. So, yeah, question?
What's a slug advice that needs to be compiled?
Good question. I'll talk about slugs in just a couple minutes. So yeah, we have this concept called a slug. And we'll actually see a slug working, slithering its way in just a few minutes. So I'll get to that. Any other questions before I go? Okay, so I'm gonna, so on Heroku we can run any Java essentially. I've picked for this demo to use Spring Brew. Has anybody here used Spring Brew? Anyone? Okay, has anybody heard of Spring Brew? Okay, cool. So Spring Brew, you may have seen it for your first time tonight. It's a rapid application development tool. It creates a Spring MVC Hibernate application. So really just some typical pieces that we have. I'd like to just tempt fate and see how many things I can try to get to break. So I'm going to actually start from scratch. And that's the reason why I'm using Spring Brew, is that I'm going to start completely from scratch, build an application, and then deploy it on the cloud with Heroku. And I'm just trying to see how many things I can throw into the mix to see what I can break. So we're going to start with Brew, create an application with Spring Brew. And really, you don't have to use Spring Brew on Heroku, just purely that's the demo that I've chosen to use for tonight. And then we'll get into Play Framework. I'll show you how to build a Play Framework application. And we'll see some Scala stuff too. Okay, so let's go create a new project. So I'm going to create a directory for it called Pets. And then I'm going to start up the Brew shell. So Spring Brew, you can download the STS, their Eclipse suite. And it has Brew support built into it, so you don't have to use the command line on your system. You can use an IDE as well, but I like the command line. So there's a sample file in Spring Brew that comes with it. It's called Git Clinic. And all that this is a bunch of Brew commands. So the Brew commands are like, create a domain object with this name and these fields, those sorts of things. So this is running that pet clinic script of Brew commands. And this is what's then generated in all of my Java classes. And then they also use AspectJ behind the scenes in Brew to weave in some additional stuff into these classes. So it's generated a bunch of that. We'll see that code in just a minute. But there's a few things that I want to do in here. I need to set up the persistence. I'm going to tell it to use Hibernate as the provider, and then set the database to Postgres. The reason for that is that on Heroku, we get a free database with us. When we create a new application on Heroku, we're just going to get a Postgres database provision for the application. And so I'm just configuring this application to use Postgres and Hibernate. You can use any database you want on Heroku. I'll talk more about that in a little bit. But this is just so that it'll work out of the box with the Heroku app.
Could you use my buckets instead of Hibernate?
We probably could. I've never tried it, so it might break my demo, but let's see if it's offered as an option here. So, sorry, this is not an option in Brew. So we get OpenJPA, Hibernate, Eclipse Link, and it's got to be Eclipse. Sorry, maybe there's a plugin for it. Okay, so next thing I need to do in here is my database is automatically configured to read the username and password out of a file. And on Heroku, I'm actually going to be able to get the connection information to the database out of an environment variable. And so I'll talk more about that in a little bit too. But I need to configure this project to read this environment variable and set up the database connection based on that. So I can run this Heroku setup. Heroku is a plugin for root, and so that just makes a few changes to this to the project configuration to handle that. Now let me go to IntelliJ, and let's go open up this project so we can get a better feel for what's going on here. There it is, pets. Open up that Maven Build.
Did we create that?
It did, yeah. So this is all been created from root. So root's generated all the stuff that you see here. No, so IntelliJ just has first-class support for Maven Pom.xml. So in IntelliJ, you could of course have with M2 Eclipse open this project up in Eclipse as well. Okay, so let's take a look at what we've got generated here. I've got some Java objects, and we'll take a look at this pet. So this is my pet entity object. Pretty simple, straightforward stuff there. Should be pretty typical to what you're familiar with in typical Java web applications. I have my controller. That's for the pet controller. It's pretty lightweight in root because it knows how to do a lot of these operations. Just built into root. Then let's see what else we have in here. My Spring configuration and JTA configuration. Let's take a real quick look in here at what that Heroku setup command did. So you'll see that I'm pulling the database URL environment variable and then using that to set up my database connection. So I'll talk more about this in a little bit, but that's a way on Heroku, that's an optional way on Heroku that we get the database connection information through an environment variable. So that's been set up there in the Spring config. And then we've got our typical web app directory and our views, and you can check out the list.jspx. So really, this is just a standard Java web application. I picked this one just to show you that your stuff, whatever it looks like, would run on Heroku. Because this is a pretty typical setup. Okay, so and then last thing to show here, actually two more things. So this is my Maven build. I want to point out one thing in here for this project. So on Heroku, we actually don't give you an application server. So some platform as a service providers, they provide an application server for you, and you deploy your application into that application server. We felt that was too limiting. We didn't want to do it that way. We wanted you to be able to run essentially any application server that you want. But there is a trick to that. You have to get your application server to Heroku somehow. There's a lot of different ways to do that. You can just put it into what you upload to Heroku. But the preferable way is to actually specify the application server that you're using as a dependency of your application. So I'm using the Maven dependency plugin and telling it to pull Jetty into my application as a dependency. So the reason for this is that now when I run this Maven build, it'll actually pull Jetty into my slug file, which we talked about in a few minutes, and then I'll be able to use that Jetty to start up this application. This is just one way to do it on Heroku. You can, of course, use Tomcat in the same way, and many other application servers as well in this way. So that's my Maven build. Then let's take a look at one last file here. So for Heroku to know, because we let you run essentially anything that you want, you have to tell Heroku what process to actually start to start up the web process on the system. So there's one file called a proc file, and in this case, there's just one line in this file. And what it says is run this Java command when you want to start up a new node. We call them dynos. So we'll get to some of the lingo in a little bit, but so there's this dyno, it's the node that's going to run this application. We need to know what process to run on the system to start it up. So we're just telling it to run Jetty Runner, pointed at the war file. We do have that environment variable for the port that you listen on our bridge. Yeah, question?
I was curious, I was assuming that all that Maven code, Maven Pom was generated, yet it doesn't seem to have consistent spacing.
You're right, it was generated, and the Spring Brew stuff that generated it did a bad job of consistent spacing. So it must be bugged somewhere in Spring Brew. I don't know why it doesn't have consistent spacing. And you even saw some tabs in there, which just drives me crazy, right? So
that wasn't the Heroku plugin.
So the Heroku plugin did add that section for the Maven dependency plugin with the tabs in it. And I should go in and, it's not my plugin, somebody else built it, but I should go in and get them to fix the tabs, right? So, yeah.
So, what about different versions of the JVM?
So there is a way to do it. The default JVM that we provide is OpenJDK 6.022 or whatever. but there is a way to overwrite that. And like you bring your own application server with you, you can bring your own JVM with you to set up a different version. We are, of course, looking at making it possible to choose either JDK 6 or JDK 7 easily. Today, it's just OpenJDK 6 is the only one that's available by default, but you can also vendor in your own JDK. If you need some JDK, you can bring it with you. Other questions before we go on? Okay, I need to make one quick change in this application, or I will have a problem. So the default, for some reason, is to recreate the schema every time I restart this application. That's not what we want when we run in production, especially when we start adding new nodes. We don't want the schema being destroyed and recreated every time. So I'm going to change this to update. Okay. So then, this application, one thing I forgot to say about the proc file. So this proc file is really the only thing about this application that is specific in any way to Heroku. Everything else about this application, 100% portable to any place you want to run it. Heroku's not trying to lock you into any specific APIs, anything like that. This is really just a standard Java web application. You'll not see any Heroku API calls, anything specific to Heroku in this application. So the proc file is really the only thing about this that's special. Yes?
So to illustrate what you just said there, your proc file could just be a jar that runs a command like Java application or something like that.
Yep.
That does some batch processing.
Yep, yeah, so good point. So we have, this is an example of a web application, and so we tell the proc file for the web process, run this command. But you can also run dynos, we'll get to that in a minute, but we can run non-web dynos. So we can say, we can come up with another process called foo and tell it to run some other Java command, which would be like a background process that isn't being routed HTTP connections and those sorts of things. So yeah, definitely. Okay, so we've got this application. I'm not going to run it locally. We're going to skip that step. What I'm going to do is just deploy this on the cloud. So to do that, one of the ways to do that is I need to get these files for this application up to Heroku. I'm choosing for this demo to upload the source files in the Maven Build and then let Heroku run the Maven Build on this project on the cloud. The reason for that is that I'm working off my MiFi, and it would probably wait all night for me to upload a WAR file. That wouldn't be a very good demo. So I'm choosing to instead upload just my source code and my Maven Build information, and then Heroku is going to run the Maven Build on the cloud. The dependencies are going to download much faster than I can upload WAR files, and then it'll create the slug file. We'll talk about that in a second. So to do the upload, Heroku uses Git as the actual upload tool. So instead of using SCP or FTP to upload files, we chose to use Git as the upload mechanism. If you're not using Git for your source control, that's okay. You can still have a Git repository along with your source control system and upload that. If you don't want to upload your source code, if you want to put binary files into a Git repository and upload those, you can do it that way. We don't care what you put into the Git repository that goes up to Heroku. Totally up to you. So let me create a Git repository. And then I'm going to add my files. So I'm going to add the Maven Build file, the source directory, and the proc file. And then I'll commit those. So I've committed all those into the local Git repository. Now I do need to tell Heroku to create a new application for me on the cloud, provision a place for me to put my application. So today the primary way to do that is through a command line tool. So this is a tool you would install. And then I just run it with Heroku. I'm going to say create a new application on the Cedar stack. That's my list at Heroku. I've been doing Java since like the early days of servlets and had a lot of fun. And went off into Adobe for a while, did some Flex and Java stuff. And now I'm at Heroku. So Heroku is owned by Salesforce.com. We were acquired about a year ago. And so thanks for coming tonight. I want to make this as casual as possible. If you have questions at any time, raise your hands. I'll try to save some time at the end, but definitely feel free to just stop in any time, and we'll kind of take this in the direction that you guys want to go with it. So let me pull up a couple slides. So this is going to be about running Java, Play, and Scala on the cloud with Heroku. I'm really only going to try to spend a little bit of time in the slides and try to spend a lot of time in code and building some applications, deploying them on the cloud. So hopefully that's okay. Hopefully you guys, if you want to see slides, I can show you slides instead, but more fun for me to write code, so hopefully that's okay. So let's see, jump in. So I started thinking about, like, this is a really ugly slide that I just was starting on today. I started thinking about what are some of the emerging trends in our world, how do they relate to the cloud? And I think there's kind of 4 major trends right now that are changing a lot of how we build applications, how we deploy applications. I'm not going to go into details on these. I think I'm going to try to highlight these as I talk tonight. But I think the point is that there's a bunch of things changing in our world right now. And the cloud is really the center of a lot of what's changing. The reason for that is that the cloud allows us to be able to build much more rapidly in infrastructure and systems. So that's why I think it's interesting to be here talking to Java developers about the cloud, because our world is a stack, and then Cedar is the name of the stack. Cedar is the 3rd generation of Heroku. It's the one that supports Java and Scala and Rails, Rails as well. So I'm using the Cedar stack for this application. So now I've already logged in from the command line. It knows who I am. So it's now making an API call to Heroku as me and saying, hey, create a new place for James to upload an application. And then it should assign me, hopefully, go 4G, go. We can get some reception, better reception somewhere.
James, there is free Wi-Fi here.
There is?
I didn't mention that.
Oh, I should have. Okay, we'll hope that it's working. We're not going to use it a whole lot. So I've got an application now for Vision on Heroku. It's assigned a randomly generated name for me. We get Evening Ocean 4627 tonight. We can give it our own name. We can point our own domain name at this application. So this is just a default randomly generated name. So I get the HTTP endpoint. I can also set up HTTPS. And then I get a GET endpoint as well. That GET endpoint is actually going to be the place that Git uses to upload the actual application up to. So let's go check out this HTTP endpoint in the browser and see what it looks like. So there we go. I haven't uploaded my application yet, so now I just get the default page, but it looks like it's responding, so that's good. So now I'm just going to take my application that I have locally and push it up to Heroku. So I do that with Git Push. Heroku is the name that got assigned to that Git endpoint. So this Git endpoint was given a name in the Git configuration called Heroku. And then I'm going to push to the master branch. Yeah, push it.
So when you issued the Heroku create command, you didn't specifically tell it was a web app. It just assumed that?
It did assume that. So Heroku does assume that you're going to have an HTTP endpoint. You don't have to use the HTTP endpoint if you have an application that doesn't do any HTTP anything. Yeah, it does assume that you're doing HTTP. Maybe a bad assumption.
Can we kill the welcome page in that case?
Yeah. So I'll talk about that in a moment with scaling. So I've got one dyno associated with my application now for the web process. That's just the default. I can tell it to have 0 web processes or 0 dynos for the web process, and then it would no longer respond to the HTTP requests. It would probably throw an error or something like that. Okay, so I want to point out one quick thing. So my upload was only 100K, so that it went much faster than uploading a WAR file. So now it's running the Maven Build on my project up on Heroku, and it's downloading all the dependencies for this application, which is quite a few. So it'll take a minute. We proxy and cache a lot of these dependencies, but it'll still take a minute to pull this down.
So this is all coming back from that git push command.
It hasn't returned yet. It's still, so we have a hook on git push, and the command's not going to return until the build is finished. If the build fails, then you'll of course see the build error in your console as well. You can do the git commands from Eclipse or IntelliJ as well. I like the command line git, but you're free to do the git stuff however you want.
So if the build fails, then git push will fail.
Yes. Yeah. Exactly. Yeah.
Did you say Rails or Grails?
Both. So we support both Rails and Grails. So, okay, cool. So what happened was we ran the Maven build, and then we created a slug file. So back to your question about the slug file. So all the stuff for this application, all the binary assets, my stuff that got compiled into a jar, all my JSPs, all the images, everything from my application, and the proc file, it all goes into the slug file. So the slug file is really everything that my application needs to run. So we take that slug file now, we copy it onto a dyno. So we have one by default. We'll get into more in a second. But copies that slug file onto a dyno, and then starts up the web process to find the proc file to start listening to HTTP requests. So now if we go back to the browser and hit reload, once we compile some JSP files, then you should see the pet clinic up and running on the cloud. Ta-da! Okay. So now I can go in and create a new pet. So this pet will be automatically stored into the Postgres database and is allocated for me. So let's go add in my dog named Wolf and save him there into the database, and looks good. So there we go. It's all functioning. It's up and running on the cloud. That's great. So now this application, it's getting lots of requests. We need to scale up. Right now we're running on one dyno. So the load balancer is just routing all the requests back to one system essentially. And I need to scale up quickly. So the way that I do that is I say Heroku scale web equals 5. So now this will start up 4 new dynos. I already have one dyno running, and I want to get to 5, so it's going to start 4 new dynos, copy my slug file onto those 4 dynos, and then start the web process on all 4 of those. And we can use Heroku PS to see what all is going on. So all these commands I'm running, these Heroku commands, they're really just calling REST APIs on Heroku. So that's that 4th point that I was talking about, management, logging. We haven't seen logging yet, we'll see in a minute. But the management is that Heroku provides everything as REST APIs. So this command line client, it's actually written in Ruby, unfortunately. We've actually written a Java version of wrapper around the APIs as well, which we'll be rolling into like things like plugins, possibly in the future and that sort of stuff. But yeah, so this is making a REST API call. You'll see that I've got all 5 dynos. 3 are still starting, and we should be all up and running. Good question.
So this is the point at which you have to start paying.
Yeah. So at this point, I'll talk about pricing in just a minute. But yeah, at this point, I will be.
How much memory is good for dyno?
Oh yeah. So let's talk about dynos. So I'm now running on 5 dynos. What is a dyno? We came up with this word dyno. The reason why we came up with a new word dyno instead of calling it like servers or instances or something like that is that this is a platform as a service. On Heroku, these are actually Linux systems. We actually take a Linux server and we divide it into a bunch of pieces through what's called LXC, Linux LXC. So it's like a small container format on Linux. So we take a Linux system, divide it up into a bunch of pieces, and then these are what dynos are. But we manage these dynos. They are not something that you can really do whatever you want on. They are managed by us. We can restart them at will, essentially. Try to be, not damaging to what you're trying to do. But these dynos are managed by us. If there's security updates on the Ubuntu system that's running these, we'll handle those and restart dynos. So it's really a managed environment. You can't even really SSH into one of these dynos once it's up and running. So we really don't call them servers. We don't want you to think of them as servers. They're really just an execution environment for a slug file. And that's just the way that our platform as a service works. Is we've got this, management layer where we manage dynos. We call it the dyno manifold. Allows us to spin up and spin down dynos and all that kind of stuff. But yeah, so we've got dynos. Dynos do have a specific amount of resources allocated to the dyno. So physical RAM is 512 and then essentially unlimited swap. That is a soft limit that we can potentially increase for the right customer. But that is the default limit.
So the pricing model, we have more dynos, but we can't sell like a bigger dyno with more memory?
I think if you're the right customer, you probably can. But today, the model is the only thing, every dyno is the same. Every dyno has the same amount of memory. So it keeps our model very simple. Dynos cost 5 cents per dyno hour. And it's essentially, you can saturate the CPU, you can do whatever you want on that dyno. You can use all the memory, whatever you want to do. But today, dynos come in just one size. It's definitely something we're looking for feedback on. But yeah, today that's the model. 5 cents per dyno an hour for these dynos. Yeah, question?
Do you have a restriction on system calls?
No. You can make any API call that you want. If you want to call system.exit in your application, you can call system.exit. The dyno manifold will notice that your process has crashed if you call system.exit, and it will try a few times to restart it. And if you keep calling system.exit, eventually it's just going to give up. But we don't limit any API calls. The file system, which is probably your next question, is writable. You can write to the file system, but it is ephemeral. I think that's the right word. It's a new word for me. It goes away. It's these dynos. Once we shut down a dyno, or once you turn off a dyno, the file system that you've been using is gone. And so the model that we move people towards is, instead of trying to use the dynos for any type of state, I'll talk more about this when we talk about load balancing, but you don't want to use a dyno for any state storage at all. Any state storage that you need to do external to the dyno in a separate tier that can be scaled and managed separately. So for file system type of stuff, Amazon S3 is a great option for storing files. We actually run Heroku on Amazon in Amazon East. And so if you want to use Amazon S3 in Amazon East, it's really low latency from a dyno to Amazon S3. So that would be a great place to store files that would be persistent across the life of the dynos. Yeah, question?
So what about the database layer then? So it seems like scaling the computation is always the easy part, right? I mean, this isn't very difficult to do this, right? But the difficult thing is scaling the database layer. So it's, you're writing these somehow.
Great question. So we recommend always to talk to an external system. The database that got allocated for this, all 5 of my databases are going to be talking back to the same database in this case. The freebie database that comes with this one, it's not a super scalable database. It's the freebie layer. We do have an enterprise level Postgres service. You can use things like Amazon. They have a really cloud scalable database. They have RDS. We have database.com. So there's really lots of different options that you can use on Heroku for how you want to address scalability. But the point is that you've got a layer of dynos that's separate from your persistent storage places. And if you want to do like relational storage, then and you need that relational storage to be really scalable, then you could go with Amazon RDS's Oracle support. You could go with our enterprise level Postgres support, or some other option like that. But it is a separate tier that you would scale separately from your dyno tier. Yeah.
Well, a different question, but another thing that I know Amazon has real problems with is the network stack doesn't really scale. Like if I saturate my dyno node,
Right.
does George's system suddenly go really slow because he's actually sharing?
Yeah, the noisy neighbor problem.
Right.
So we use Linux LXC to define constraints on the ways that we partition a Linux system. And as far as I know, Linux LXC is pretty good at dealing with noisy neighbors because it's really a low-level Linux thing that is down at the low level of dealing with system calls and CPU time and all that kind of stuff. So I haven't heard that the noisy neighbor thing is a problem on Heroku, but maybe because Heroku lives on top of Amazon and we actually run on EC2 instances, maybe we'd have that problem, but we're probably running large enough instances on EC2 that we wouldn't have a neighbor in that case. So I haven't heard of this being a problem on Heroku, but it certainly is potentially there since we are running on EC2. Yeah?
Do the dynos have stickiness? Do you have a distributed cache of the dynos?
That's exactly where I was going. So hang on that 30 seconds and I'll talk about that check there. Yeah, so we're running on 5 dynos. You guys are leading me through this demo perfectly. It's like you guys know what's coming next. Okay, so I'm running this application on 5 dynos. I'm going to open up a logs window here so we can see the logging output. So the logging system on Heroku is called Logplex. It's a central logging system. I think it's built in Erlang. And all of the standard output dynos and all of the routing infrastructure on Heroku all logs messages to Logplex. We can view those logs through the command line like this. We can make API calls. We can get a pipe of the logs to somewhere else. There's Heroku add-ons that take a feed of the logs. So there's different ways to deal with the logs, but essentially everything logs to Logplex, and then we can get that information out in different ways. So let's go and check out this application here in the browser. So this particular page, this list all pets, I'm probably using the JSP that needs to compile. This list all pets is going to make 20 requests, HTTP requests back to the server. So for images, CSS, JavaScript, all that sort of stuff. So on Heroku, the load balancer is there automatically, and it's automatically going to route all of those requests across all 5 of the dynos that are up and running. If a process is exited on one of the dynos, it's not going to be routing traffic to that one, obviously. But the only good way to kind of see what's going on is through the logging system. So if we go look at the logs here, we can see that this request went to Web 1, this one for this PNG went to Web 2, let's see, one to Web 4, and we should see all 5 of the dynamos are being routed requests to. So Heroku today does not support sticky sessions. This is back to your question. The problem that we found with sticky sessions is that sticky sessions usually mean that you're doing session replication as well. And session replication, from everything we've heard from our customers, is that it's really not a scalable way to build systems, especially cloud systems. And so what we do instead is we say, all right, if you have state in your application in memory, you actually should not hold it into memory because we can't route all the requests back to that dynamo. It kind of violates part of the principle, the server affinity principle that we're trying to make this dynamo manifold. You know, this request can go anywhere. We can take dynamos out. We can update the application. We can do all this very easily. But what that requires us to do is take our state out of our web tier and move it into an external system. So the easiest way to do this is to choose a web framework that actually doesn't have any session state. So Play framework, which we'll talk about in a little bit, it doesn't use any session state. There's, as far as I know, no way to do session state in Play framework. So that's a great option. Go stateless in your web tier. If you can't go stateless because we're using some web application framework that has state use built into it, or we just need state for something that we can't get away from, you could potentially rewrite that code that is, talking to session.get attribute, session.set attribute. You could have it talk to an external system like MongoDB or Memcache. You can do it that way. Or with Jetty and Tomcat and probably others as well, you can actually transparently have the application server move any calls to session.set attribute and session.get attribute, have it move those out into an external system like MongoDB or Memcache or something like that. So that's very easy to do. I have a blog post that goes through how to do it with Jetty. But that's really the preferred approach, is that you take that state, move it into an external system, just like we talked about with file system, and scale that system independently and separately from how you scale your web tier. So, yeah, question, Ted.
Well,
Thanks for coming.
you're welcome. The logical equivalent to session in order to be able to tie it to external state, there was always a session ID.
Yep.
In the serverless JSP world.
Yeah, yeah.
And I haven't seen moral equivalent to that in the Play framework, so I can in fact put that session state into an extra. Do you know, maybe this is something you go over in the Play
Yeah.
section. Do you know if there's a
So usually we actually just end up using cookies for this. So we put a value into a cookie and we say, all right, and then when we get that cookie information on a request, then we can look up into an external MongoDB system or some or Memcache system and use that as our token to know who the user is.
But
then
Play doesn't set anything like that up for us.
There is a way in Play Framework to do that.
Okay.
Yeah, there is a way. They even have a way to encrypt those tokens. So we can look more into the API on that in a little bit. But yeah. But session tokens are a place where we run into this a lot. Even with things like Spring Security, it does require session state. And so that is, even if you wanted to run an application on more than one dynamo with Spring Security, then you would need to move your session state out, even if you're not using the session state anywhere else in your application. So there are definitely a lot of the older Java web frameworks that use session state for this sort of thing.
Yeah, and that's where I was going. Specifically for security, we don't really want the database every single time.
So for relational databases, there is a lot of overhead on every request going back to a relational database. But systems like MongoDB and Memcache, they're much faster at doing this kind of thing. So we've done some tests with Memcache specifically. It turns out to be not as fast as in-memory, obviously, but I think it's faster than doing in-memory with session replication, because session replication has overhead. So there's always trade-offs, obviously. But and then to your point about security, I don't know. That's a good question.
I mean, previously with the speaker that was actually pushing not using sessions, the whole issue was wanting to use distributed cache.
Right.
But that doesn't invalidate the value of stickiness. As a matter of fact, it makes the stickiness safe.
So the reason why people usually would use sticky sessions is that they don't want to have to, they want the user to come back to the server that has their session on it, because they don't want to have to make a bunch of network calls to move the session around to a different server. And so in this model, where the load balancer is taking all the requests to all 5 dynos, I have to be keeping a lot of session in sync.
Right,
And that's,
the distributed cache has local data that basically we're not taking advantage of.
the distributed cache has local data. So I don't know internally how like the MongoDB implementation of the session manager for like Jess is a stack, and then Cedar is the name of the stack. Cedar is the 3rd generation of Heroku. It's the one that supports Java and Scala and Rails, for extension Rails as well. So, so I'm using the Cedar stack for this application. So now I've already logged in from the command line. It knows who I am. So it's now making an API call to Heroku as me and saying, hey, create a new place for James to upload an application. And then it should assign me, hopefully, go 4G, go. We can get some reception somewhere.
James, there is free Wi-Fi here.
There is?
I didn't mention that.
Oh, I should have required. Okay, we'll hope that it's working. We're not going to use it a lot. So I've got an application now for which on Heroku. It's assigned a randomly generated name for me. We get Evening Ocean 4627 tonight. We can give it our own name. We can point our own domain name at this application. So this is just a default randomly generated name. So I get the HTTP endpoint. I can also set up HTTPS. And then I get a GET endpoint as well. That GET endpoint is actually going to be the place that Git uses to upload the actual application up to. So let's go check out this HTTP endpoint in the browser and see what it looks like. So there we go. I haven't uploaded my application yet, so now I just get the default page, but it looks like it's responding, so that's good. So now I'm just going to take my application that I have locally and push it up to Heroku. So I do that with Git Push. Heroku is the name that got assigned to that Git endpoint. So this Git endpoint was given a name in the Git configuration called Heroku. And then I'm going to push to the master branch. Yeah, push it.
So when you issued the Heroku create command, you didn't specifically tell it was a web app. It just
It does it. The way that I think that it does it is that it actually does keep a local in-memory cache of session, and then it has a way to invalidate the cache so that if the request does happen to come back to the same dyno that processed the previous request, then the session is already going to be there. I think that they do that in the session manager for Jetty's MongoDB session manager, but I haven't looked too far into it. Is that what you're asking?
Right. It seems to me that you would end up with a situation where by distributing the thing that makes it, and even one of those requests had to be validated, that you are inherently then putting a bottleneck on the Memcache layer.
Yeah. There's certainly a trade-off here. So we're not making an in-memory call to validate some session ID. We would have to go across the network for that. Memcache is going to be the lightest way to do that, and it's about 3 milliseconds to do a read out of a Memcache system for a value. So 3 milliseconds, it's not as fast as in-memory, but it's not going to probably kill the performance of our application. But they're definitely a trade-off.
Values on a different node.
Yeah. That's 3 milliseconds is for a network call to a network request to a Memcache service. Yeah. So Memcache is going to be the fastest way to do it. MongoDB gives us better session or storage durability, but the trade-off is performance. If we went all the way to like relational database, we're going to take a big trade-off for performance. We're talking like 200 milliseconds to make a read, that kind of thing, depending on queries and that type of stuff. Yeah.
Walk me through how my logging gets to your login.
So just standard out.
Log from J or
All you have to do is output the standard out, and we take all standard out output and route it into Logplex. So everything that your dyno is outputting to standard out all goes into Logplex.
And if I have 4 log files for subsystems within my application.
So if you are storing 2 files on the file system, then you're writing to an ephemeral file system, and those would go away when the dyno restarts.
So logs.
So that's why we recommend outputting to system out instead, and then we have tools and add-ons to deal with logging in system out. Or there are adapters that will, instead of storing log files into files on the file system, will store them into like Amazon S3 for persistent storage, that kind of thing. So there's a lot of different options depending on what you want to do. Okay, yeah, question back there. And we'll move
So
on.
if I want to make tweaks, since I can't SSH into all my tweaks, does that require Git template to make tweaks on?
Great question. So if we want to make an update to this application, if I want to go make a change to some file, let's actually try it out. So let's do something in, let's see, back into our list, JSP pets list object here, and do some hello world. Very exciting there. So I've got this change locally. Now I want to push that into the production, all 5 dynos. So I would do a git commit. So let's do our git commit minus am. That'll add and commit this change. And I'll be like, hello. And then I'll do my git push Heroku master. So now this will take the delta. So Git's pretty smart about what it transfers up. It'll take the deltas, upload them up to Heroku, rerun the Maven build, create a new version of the slug file, and then deploy that new version of the slug file onto all 5 dynos. So it's pretty smart about how it does the redeploy. So we've got a pool of dynos running. So when this build finishes, when the Maven build finishes, when we've got the slug file, we're going to send sig term to all 5 dynos that are up and running, tell them to start shutting down and stop handling requests. At the same time, we're going to take 5 new dynos, deploy this new version of the slug file onto the 5 new dynos, and begin bringing those 5 new dynos up. At the time when we're kind of between dynos, for that maybe 10, 20 seconds, the load balancer is actually going to be holding HTTP requests at the load balancer layer, saying, all right, hey, request, hang on, and the browser's going to spin. It's not going to return here, so the browser's just going to spin. And then as soon as the new dynos are up and ready, then the request will get pushed through to the new 5 dynos. So all that should have happened already. And if we go back to the browser and check out our list all pets, hopefully we'll see my hello world somewhere in there. It'll take a second to recompile JSPs. It's one of the downsides of using JSPs. Internal error. Demo fail.
You get demo debugging.
Let's see. Logs. What a break. You know what I bet I broke is my JSPs.
Yeah. Yeah, right. This is a like
I probably should run this through a staging environment first. Local testing.
This is like really done.
Let's try it that way. I think it was a JSP compilology, right?
Yeah.
You got a message. Who
Your ID
a message?
even told you.
Big old stack trace. My ID did tell me. Just listen. Content is not allowed in trace section. Line 15. Okay. So let's try this again. So I would obviously in a real world not be pushing to production directly. There's a few different ways that you can do that on Heroku. You can set up a continuous integration environment to push from continuous integration to a staging environment, and then verify builds and push those to Heroku. Lots of different ways to do it depending on how heavy or light you want the process to be. If you want it to be really lightweight, you can just push to production like I'm doing, and hopefully we'll get a network 4G code. There we go. Okay. That was only 748 bytes I had to upload. We run the Maven build and we deploy. We also support Gradle. Forgot to mention that earlier. So Gradle support it as well. Yeah, question.
That's what's going on. So it's cool that you're using Git to do this nice delta. Is the slug stuff as smart as that? It seems very odd that then slug up the whole thing. So
That's a good question. Are our slugs deltas? We do keep all the previous versions of slugs, so I don't know if we're actually deltaing the actual slugs. That would be the really smart thing to do.
Yeah.
Slugs actually today get stored in Amazon S3, so it would be smart of us to do deltas so we're not paying for all that storage.
Right.
Yeah, I don't know what they actually do.
But it's funny, it's fine. Once that's 2 gig, this process is not going to look so clever, right? I mean,
Right.
that wait for that 20 seconds, maybe 20 seconds.
Right.
You're going to push the gig slug over.
Yes. All right, let's see if I fix my JSP compile problem. So GitHub says they pushed, on the GitHub.com website, they say they pushed to production like 20 times a day.
So the main model is just per node, not per site.
So it is per dyno hour. So it's 5 cents per dyno hour. So the way that we give developers Heroku for free essentially is every application you create on Heroku, it's 750 free dyno hours per month. So if this application I just created, it's going to get 750 free dyno hours for each month. And then any other application I create, 750 free dyno hours per month. So at the end of every month, Heroku is going to count out how many dyno hours I use. It's going to subtract the 750 free that I got, and then it's going to multiply it by 5 cents per dyno hour. And that's it.
And that's like CPU time? Or?
This is where it gets a little tricky because Amazon has this concept of EC compute units, EC2 compute units. It's like their theoretical CPU. They tell you it's kind of like this CPU, but we're not really sure what it actually is. It's just some made-up term. We haven't yet defined how much CPU power every dyno gets. It is some slice of an EC2 server. I don't even know what size EC2 server it is. But so yeah, we slice up an EC2 server. We give each dyno a specific amount of CPU resources, and we don't clarify, we don't even have a term for how many compute units or whatever a dyno gets. It's something I think we should define, but we haven't. Yeah.
So if you're supplement something where you keep yourself, you get a bill or something like that, or what?
So as a developer, you can get started on Heroku without even providing a credit card. As soon as you provide a credit card for Heroku, you can start scaling beyond one dyno. But if you leave all 5 of these dynos running for a month and you forget about them, you will get a bill for essentially 4 dynos for the month. And they will charge your credit card. So this is one thing I wanted to point out about scaling. So some platforms provide auto scaling, where they say like, no matter what your demand is, we're gonna scale up to meet that, and we're gonna scale down automatically. Heroku, today we don't have a concept of auto scaling built into the Heroku platform. We provide the APIs to get information on what's the wait time in the load balancer, how many requests per second are you getting, and then the APIs to do the scaling. But today we haven't done any auto scaling directly in the platform. The reason for that is that because we let you run anything on Heroku, we don't know where your bottlenecks are in the application. It could actually be that scaling up more dynos actually hurts your performance, right? It could actually start to degrade as we add more dynos. It could be getting worse and worse and worse. So we don't know how to scale your application. So we've left that up instead to third-party tools. There's a number of open source tools. There's a couple services out there that do auto scaling on Heroku. You go in and you configure like, all right, number of requests per second, set some thresholds and tell it how many dynos to add. So there are services that do that. They're just built on our APIs. There's open source projects on GitHub that do that. So there is ways to do it. We just haven't built auto scaling into the platform.
So if I'm just playing around,
Yep.
and I play around with 750 hours a month, what happens then?
Nothing. You'll get a bill for $0.
But like cut off?
No. Well, so your dyno is, if you leave a dyno running for a month, so I've done Heroku scale web equals 1. That means I've got one web dyno running my application. As long as I have not changed that number of dynos, that dyno is going to be running, and counting dyno hours and counting dyno hours. And when it gets to the end of the month, it's going to take all the dyno hours that I was running for, and if they're under 750, which one dyno for a month, if it's a 31-day month, it's like 740 hours or something like that, you're not going to have to pay me. But is that
It's 31 and 40 days.
31 and 40 days? It's 750 hours.
Why don't you rely 40 days in the month?
It's a ticket consideration.
I'm not sure. They give me my 40 days. It's very hard. It's fine. It looks like it's my 4G. A little one. There we go. Hello world. Yeah, yeah. The 4G being a little weird. So there we go. So now I've got my update now going on. Sorry, back to
So if instead of just adding hello world, you actually the schema change, you have some code that needs to run to migrate the schema.
Yeah.
How would that fit into this whole?
So it's going to depend on how you do your schema migrations. There's obviously Maven plugins that will do schema migrations. There's Play Framework has its own way of doing schema migrations. If you need to actually get into remote into the database, the freebie database, the freebie Postgres database that comes with Heroku, there's not a good way. There's some tricky ways, but not a good way to remote into that, get an actual connection, remote connection to that database. But our enterprise level Postgres service does provide that. If you run your own database on Amazon, or you run Amazon RDS or some other system, then you could get remote access to your own databases, obviously.
A lot of tools they just look into the application starts, they
Right.
go and
Yep.
check that. So how does this work? You're actually starting up like 5 in parallel, and just like existing with other old nodes still running.
So I don't think it's going to be different than any other environment that you would manage on. Obviously, your migration scripts are going to have to know that the table is locked or something like that because somebody else is upgrading it, then to not try to do it again and that kind of thing.
So you
So,
mentioned the new nodes won't handle any requests until the old nodes have stopped handling requests.
no, as soon as the new ones are up and running, the load balancer starts running requests for them.
So examples doesn't at the same time.
Technically, yes. So it's going to begin shutting down the old ones and bringing up the new ones at the same time. But the load balancer is not going to be writing requests with both at the same time. It's going to be holding those connections from going to the old ones while the new ones are coming in. Okay, more questions?
How durable is that freebie database that you have in terms of, is it breaking down a little?
Yeah, the freebie one, it's not really recommended for production. It's great for demos. People do use it for production, but it's not recommended. If you go to status.heroku.com, you'll see some outages on the shared database. So it's not the most reliable thing. Honestly, if you want a cheap option that you have more control over and want to deal with your own database stuff, you can set up an Amazon EC2 micro instance. It's about, I think, $18 a month. Run MySQL on that, and then you're totally at your will to do whatever you want. Or there are some other add-ons for MySQL and that sort of thing. So the freebie one is great for demos. I wouldn't really recommend it.
What database is it?
Postgres. The freebie one is Postgres. Okay, let's keep moving. Okay, so we've gone through, let me see if I missed anything. I think we've gone through all this. So instant deployment, Git push, moving through that. One thing to point out, I created this little app, java.herokuapp.com. What it does is it allows you to take some of these demos that I'm showing tonight and clone them, so it creates a copy of the application, and then it's all yours. You can do whatever you want to it. You can Git pull it down, you can make changes to it, Git push it back up. So it's a pretty easy way to get started with Heroku. So check that out if you want to take one of these demos and play with it on your own. We talked about load balancing, CP sessions, talked about scaling, work processes, I mentioned a little bit. Heroku logs. Oh, Heroku config, let me show that real quick. So if I do a Heroku config, we use environment variables as a way to provide runtime configuration information to the application. And so you'll see it here. There's a database URL environment variable. This got set by what we call the shared database add-on. So the Postgres database that got added automatically for this application, that went off and provisioned a database for me, Postgres database, and then set an environment variable for all of my dynos in this database URL. So we see that there, it's all gibberish, whatever. Part of the reason why we use environment variables for this instead of putting this information into text files is that when you come to cloud services where someone else is managing this service, there could be a reason why they need to change this URL. Like we need to fail over to some other server. There was actually an issue that we had with, we weren't generating passwords securely enough for the databases at one point years ago. And so we actually had to reset everyone's passwords. So you can imagine if we had to pick up the phone and call all of our customers and say, hey, we got to change your password, you got to go, make a change to your this config file, you got to re-upload a new file, and all that kind of stuff. It just would have been a nightmare. So we find environment variables to be a good way to manage this type of information. You can of course set your own configuration variables. You say Heroku config add in your own environment variables, and those are just available to all the dynos that are running the application. Okay, so that's config options. Oh, one other thing to point out here. You'll see that this format, Postgres : / this is not the JDBC format. Because Heroku is a polyglot platform, we have to provide this connection information to a number of different languages. So we can't make it JDBC : Postgres : whatever it is for JDBC. So you do have to take this format and tweak it into the JDBC format. Play Framework has support for this style of URL, database URL that's built into it. I think Spring Brew added this recently as well. So you do, if you are connecting to the database in your own way, you are going to have to read this environment variable, tweak it into the right format. Yeah.
So is the authentication information embedded in that URL or something?
It is, yeah. So it's this typical URL format where it's the protocol, the username, colon, password, @ host, / resource name.
And then, sorry, one more quick follow-up question. The Java ops there, the VM is explicitly specifying like maximum memory and stuff in there.
Yeah.
You mentioned they only have like 512 meg resident and then swap after that. So it really doesn't matter what you put in there, I guess, beyond just limiting it in the sense that it'll always issue 512. And
Yeah, exactly. So I don't, it looks like, I don't know why we set the default limit to be 384, but we could obviously go in and change that. I guess there's probably some system memory overhead or something, but.
I'm already using a 64-bit JVM, which is only 500 megabytes available.
Good
You see the last flag there?
We should just be using a 32-bit one, huh?
You see the last flag there? That
Yeah,
does
that
that.
as well, just
And also that is done by default in the model. So if you use less than 4 gig, it will use 32-bit.
Oh.
As of like, I don't know, 7 or 8 reps back.
That's great. So then we use less memory allocation, like we use 32-bit
pointers,
pointers. So
Of course, what that does to your lookups, I couldn't say exactly.
yeah. Okay. One more question.
So you mentioned there's a login to Heroku. I
Yes.
assume that there must be something to like switch which app you're using, because you might have more than one app and all these commands you're not following.
Great question. Yeah, so when I run these Heroku commands, it knows what application I'm using because of my git config. So the Heroku command line client actually looks at my git config to determine what application I'm referring to. I can always override that. I can say Heroku does it. The way that I think that it does it is that it actually does keep a local in-memory cache session, and then it has a way to invalidate the cache so that if the request does happen to come back to the same dyno that processed the previous request, then the session is already going to be there. I think that they do that in the session manager for Jetty's MongoDB session manager, but I haven't looked too far into it. Is that what you're asking? Is that
Right. It seems to me that you would end up with a situation where by distributing the thing, basic, and even one of those requests had to be validated, then you are inherently then putting a bottleneck on the Memcache layer.
Yeah. There's certainly a trade-off here. So you're not making an in-memory call to validate some session ID. We would have to go across the network for that. Memcache is going to be the lightest way to do that, and it's about 3 milliseconds to do a read out of a Memcache system for a value. So 3 milliseconds, it's not as fast as in-memory, but it's not going to probably kill the performance of our application. But there definitely is trade-offs.
Values on a different node.
Yeah. That's 3 milliseconds is for a network call to a network request to a Memcache service. Yeah. So Memcache is going to be the fastest way to do it. MongoDB gives us better session or storage durability, but the trade-off is performance. If we went all the way to like relational database, we're going to take a big trade-off for performance. We're talking like 200 milliseconds to make a read, that kind of thing, depending on queries and type of stuff. Yeah.
Walk me through how my login gets to your login.
So just standard out.
Log4j or
All you have to do is output the standard out, and we take all standard out output and route it into logflex. So everything that you're done config -- app, and then say Java. That's java.heroku.com. This is going to fail because this particular user doesn't have access to that one. But yeah, so you can set the app manually. But it'll use that.
CD to your other project, and it'll use that one.
Exactly. Yeah.
So what if you're working in a place that uses Subversion?
So you could do this in parallel. You could have a Git repository that you use just for pushing to Heroku. Okay. There's quite a few people that do it that way. Yeah. Okay. One question here.
So just looking at the parts of the so what's the access level that Heroku, the company, like the infrastructure layer that you guys provide, does it have access, or is it some natural firewall that ensures that Heroku could not see any of the data that's being passed to a Heroku instance? Or
So Heroku ourselves, we definitely have a lot of safeguards built into the Heroku system for how we deal with that. If you, let's say, file a support ticket with Heroku, you have to check a box to tell Heroku that they can access your application. Otherwise, if you haven't given us permission, then we have systems in place that make it so that we cannot go in and see what's going on.
Trust it. So you guys do have access to that, it's just you choose not to.
Yeah, I mean, we're managing the hardware, right? We're managing the Linux instances, but trust is the primary thing that we have to provide to people. Salesforce.com, you know, if you don't trust Salesforce.com with your CRM data, you're never going to use them. We're in the same boat with Heroku. If you don't trust us, then it's a problem for us. Yeah. Okay, let's go back here. So if you want to view your releases, that's all of your, every time you do a successful Git push where the build succeeds, every time you do a configuration change, every time you do an add-on change, all of those create a new version of the slug file, and you can see all the releases with Heroku releases, and you can roll back to the previous or any release with Heroku rollback. And then you can always run one-off processes. You can say Heroku run bash. That actually takes a whole new dyno, puts your slug file into a new dyno, runs bash on that dyno. Bash is just a Linux command. And then now you have an interactive console onto a new dyno. You can't bash into an existing dyno. Only these one-off processes are all on brand new dynos. Okay, so add-ons.
Take your database that way.
If there was pSQL on there, which there's not pSQL on the dyno, so yeah. But there is a tricky way to do it. There's a, actually I think one of the Heroku guys built something that basically is a one-off process that pipes stuff through there. I don't know how it all works, but so there is a tricky way to do it. So add-ons, Heroku has, I think, over 50 add-ons now, everything from NoSQL databases to relational databases to email sending services to monitoring and analytics systems like New Relic. So lots of different things. You can see those at addons.heroku.com. I'm not going to spend a lot of time on it. So these are mostly provided by third parties. They're third parties that we've vetted and really make sure that they're solid and going to be around. We really consider them part of the Heroku platform, but most of them are run by third-party services. Heroku does have some of our own add-ons. So if you want to add SSL to your HTTPS to your application, that's an add-on. There's a freebie tier and then commercial tiers depending on what you need. So there's a number of different add-ons. We provide a few. Most of them are run by third parties. Most of the third parties run their add-ons on Amazon EC2, so it's really low latency between the dynos and the add-ons.
Is there a market around that?
There is, yeah. So they almost all of them I think have a free tier, so you can get started with them. Like Memcache has like a 5 meg Memcache service for free, but then as you go beyond that 5 megabytes of Memcache needs, then you start paying. So there definitely is like a app store economy in the add-on system. So you can find out more on addons.heroku.com. Okay, let's talk about that. So I want to switch gears and talk about Play Framework. But any other last burning questions before we go on to Play Framework? Yeah?
You mentioned there's some ephemeral storage space. How do you use it?
Good question.
Or file that just has like all my photo albums in it and upload it.
You could do that. It would go away. It would not last long. I think we restart dynos pretty frequently, potentially every 24 hours. We really want people to abide by the server affinity model, and so dynos are very dispensable and elastic. So you probably could write.
Well, he's checking his photos into your Git repository.
Into your Git repository? Into the Git
And
repository.
building this out and then bringing up his
So we do have a soft limit on slug file size of 100 megs. So we do obviously have some protections in the system so that people don't abuse it. We do get people trying to abuse it, and so we do have to put in safeguards to protect the system. So 100 meg limit on slug file size. So I think if you do a Git push, which results in a slug file larger than 100 megs, then we will reject the push on that. So you just won't be able to do it. So that is a soft limit for the right customers. We can use that, but we really try to push people to external persistent storage mechanisms and things like CDNs and Amazon S3 and CloudFront and Akamai as better places to do like large file storage.
So you know how much disk space is available for
I don't know. It's gigabytes. It's not something that you should run into as a limitation if you're using dynos correctly. Yeah, I think through Bash you could probably get in and see how big the file system is, but
You were using a plan of 100 megabytes.
okay, so, yeah. Good, I'm glad you know that. So this slug file for the application I just pushed, it was a 40 meg slug file. That's actually double what it needs to be because I'm creating a war file, but also my slug file is my whole target directory, which is basically has a copy of my expanded war file. So I've basically got 2 war files going into my slug file, and there is some ways to clean that out so that my slug file will really only be like my war file, or just my expanded directory, expanded war file directory. But yeah, so that slug file was twice as big as it should have been actually. It's going to be all of your jars that you need for your application. So you need to make sure that your Maven build is not bringing down dependencies that you don't actually need. Okay, Play Framework. Let's go on to Play Framework. Is anybody here using Play Framework? Cool. Okay. I just started using Play Framework like 6 months ago. Really been enjoying it. It's a great way to build Java web applications. The best thing about it is the fast iterations. You just make changes to stuff, hit reloading your browser, it's auto recompiling. Really great environment for building Java web applications. So definitely encourage you to check it out. I'm going to again start from scratch, try to see how much we can break, build a Play application, and run it up just so you can get a whole idea for Play Framework and how we run it on Heroku. Okay, so let's jump in real quick. I need to update this. So we support Play 1.2.3, 1.2.4, Play 2 beta, and Play 2 RC2. They released RC1 just last week, and like a day later they released RC2 because RC1 actually didn't work on Heroku. Kind of unrelated to Heroku, it's just the way that they messed something up. So RC2, Play Framework 2, RC2. And then Java or Scala. So let's go build a Play app. So I'm going to do Play new and call this foobar. I'm using Play 1.2.4, latest production version. So now let's go in here and I'm going to do Play idea, generate my idea project files. And before I go into my idea, I'm going to do Play run. I'm going to start up the Play server. And what's great is that you won't see me actually ever have to restart the server. So this is really the nice thing about Play. So let's go open up this project here. And so Play Framework has, IntelliJ has great support for Play Framework as well. You can do the command line stuff for Play in IntelliJ. I just like the command line, so that's what I did in there. So let's take a look at this project real quick. So the first thing is, in the conf directory, I have this routes file. The routes file defines the HTTP verbs, the request pass with possible regex if you want, and then the method to call to handle the request. So we have a GET request to slash, which is going to application.index. If we go pull up that application.index, which is in, let me show you, app controllers and then application.java, we have this controller, and it has a static method on it called index, and that's what it actually is handling this request. The reason why it's static is that Play Framework really wants you to think about these controllers as stateless objects. And so they really want to model the HTTP protocol of being stateless. It handles a request and returns a response. And so that's why they made these methods static. I've heard that under the covers when they do the code generation, all this crazy stuff that Play does, internally these actually aren't static methods. They haven't looked at the generated code, but to our use, it's static methods because they really want us to think about this as a stateless object. We've got this method, all it's doing is calling render. Render, by convention, will render the template based on the controller name and then the method that I'm calling. So in this case, it's going to call the index.html template. So that's in views, application, index.html. And for Play 1 Java, the language that we use for templating is Groovy. So we'll see the first thing here is we're extending main.html. If we go look at that, we'll see just a basic HTML page, pulls in Jquery, which we'll actually use in a minute. Setting a title, and then displaying a welcome message. So let's go check this out in the browser. Let's go to localhost 9000. And there's our Play app up and running. So by default, we're running Play in dev mode. So in dev mode, we actually get some documentation for Play. So all of the documentation stuff is self-contained, really easy to get started. So that's cool. Let's make a couple changes to this application. Let's come in and change the welcome message to say, hello to the world. And I'm just going to save and reload the browser. and you'll see instantly, we see that, there's none of this recompile, rebuild, redeploy, restart Tomcat kind of stuff. So this is why Play just really becomes a productive environment. Very similar to Grails. I just started using Grails and you got the same kind of feel from Grails. But the cool thing for me about Play is that I'm writing in Java, not Ruby. Ruby's a great language, but I don't know it as well as I know Java. So, okay, so let's go do something else a little more interesting. A lot more interesting. Let's go add a system out println into our controller and output something. So again, I just hit save and reload, and now if we go back and look at the console, we'll see it's outputting that there. So it's not just the templates, it's the Java classes as well as recompiling underneath the covers. So pretty cool. Okay, let's do something a little more interesting here. Any questions before I do something way more interesting? Any questions on that? Okay, so let's do a new model. Create a new model here. It's going to be a Java class. I'm going to call it bar. I'm going to create an app to store my list of bars. I'm going to extend the model class. This is optional in Play, but it provides some convenience methods, which we'll see in a minute. And then I'm going to annotate this object with @entity. So that's just the JPA .x persistence entity there. Now let's add a public string name. So I'm going to store the name of my bar. Because I'm extending model, I get an ID primary key automatically added. I can do JSR 303 validations in here as well, so those are all supported. But I'm also doing a public property here instead of a getter and a setter. You can use getters and setters if you want. Play generates them underneath the covers, but you don't have to use them. It does have to deal with just public properties. So totally up to you how you want to do it. So I've got my bar model. If I go back to the browser and hit refresh, I'll actually get a JPA error because I haven't configured my data source yet. So let's go configure my data source. So I'm going to go into application.conf and come down to the database section until the default database is going to be in-memory database. Now we should be good to go. Okay. So I've got my model. That's very cool. Let's now create a way to add new bars into the system. There's a CRUD module for Play. It'll generate a whole CRUD UI for this thing for me, but I want to do things a little more manually so you can get a better feel for how Play works. So I'm going to first start with a route. I'm going to create a new route. It's going to be a post handler for /addBar, and then that's going to call application.addBar. So now let's go and see that controller and go add in public static void addBar. AddBar is going to take a bar as a parameter. So I use bar there as my parameter, and Play Framework will automatically take my request parameters and stuff them into my value object. And we'll see in a minute when I get to the template how it figures out how to do that. But in here, let's just do bar.save. So that save method comes because I extended the model class, and I have an easy way to save, and you'll see in a minute I have an easy way to query as well. And then I'm going to do a redirect back to the index page. So I'm just going to call the index method, and that'll do a redirect. Okay, now back onto our template. So here in index.html, I want to create a little form that will allow me to call this addBar method. So I'm going to use Ruby for this. I'm going to say create a form. It's going to use the addBar controller, and then close out that form tag. Now let's do our input. So now is where I actually do the little trick that'll tell us what to map, what property to map this into. So I'm just going to say bar.name. So that's how it knows what property to stuff this thing into on that bar object. And then a input type submit. Submit. There we go. Okay, so now back to the browser. Let's hit refresh. And I get my very beautiful HTML form. I can add some new bars and hit submit. And redirect it back to the index page, so I think that it worked. We don't have a way to see my bars yet. We'll see them in just a second. Any questions so far? Okay, so let's keep going. So let's create a way now to get our bars out. But I'm going to do this, it's the new cool thing. You get JSON out and then use Jquery or something to take the JSON and display it on the page. So we're going to do it the new fun way. So let's go to our routes and create a get handler for /list bars. and then new model, new controller here for application.listVars. Go in here, public static void listVars. And then I need to render this as JSON. There's a couple different ways to do it. The easy way for me, in this case, is just called the render JSON method, which will just take an object. The object that I want to give it is going to be all my vars. So I get those by running a static method on var called findAll. There's a bunch of different ways to do finders in Play Framework, but because I extended the model, I get some basic finders for me. So findAll returns a list of vars, and those will be rendered as JSON. So let's save that and go test it out here. Let's go to /listVars. And there we go. Now we see my JSON array outputting my one var that I have so far there in JSON format. Okay, so that's pretty cool. Let's go back to our index.html. Now let's do a little jQuery fun. I just started learning jQuery. I'm a Java guy, so this web stuff is pretty kind of new to me. JavaScript is fun and interesting. I was at Matt Rabel's talk at JFocus last week in Europe. He said that there's a split happening in the developer space where we've all kind of done basic UI programming. He says that as Java developers, we're probably going to have to pick in the future if we want to be the guys who are creating the Java services and outputting JSON, or if we want to be the programmers who are consuming the JSON services and writing the client side of the application in JavaScript and HTML and CSS and Twitter Bootstrap and all these other new JavaScript MVC frameworks that are coming out, Backbone and all that kind of stuff. So I thought that was pretty interesting. We'll see if it happens. But okay, so let's do some jQuery. So I'm going to do a set. I'm going to set a variable here called more scripts. The reason why I'm doing that is, we'll see in a second here, in main.html I have this nice place to insert a script tag into the right place in the page. So that's why I'm doing it here. So let's now create our script tag, JavaScript, and now let's do some jQuery. So if we want to do when the page loads, we want to call some JavaScript. So I do that with $, and then just put a function in here, a JavaScript function. Now I'm going to do a $.get. So I'm going to make a GET request to /listVars. And then this will have a callback function that takes a data parameter. And then with my data that I get back from this JSON request, it'll be automatically turned into objects from JSON. So now what I want to do is iterate config --app and then say, Java. That's java.heroku.com. This is going to fail because this particular user doesn't have access to that one. But yeah, so you can set the app manually, but it'll do that.
CD to your other project and it'll use that.
Exactly. Yeah.
So what if you're working in a place that is subversion?
So you could do this in parallel. You could have a Git repository that you use just for pushing to the road. Okay. There's quite a few people that do it that way. Yeah. Okay. One question here.
Sorry. So from just looking at the parts of the so what's the access level of Heroku, the company, like the infrastructure layer that you guys provide? Does it have access, or is some natural firewall that ensures that Heroku could not see any of the data that's being passed to a Heroku instance? Or
Yeah. So Heroku ourselves, we definitely have a lot of safeguards built into the Heroku system for how we deal with that. If you, let's say, file a support ticket with Heroku, you have to check a box to tell Heroku that they can access your application. Otherwise, if you haven't given us permission, then we have systems in place that make it so that we cannot go in and see what's going on.
So you guys do have access to that, but it's just you choose not to.
Yeah, I mean, we're managing the hardware, right? We're managing the Linux instances, but trust is the primary thing that we have to provide to people. Salesforce.com, if you don't trust Salesforce.com with your CRM data, you're never going to use them. We're in the same boat with Heroku. If you don't trust us, then it's a problem for us. Yeah. Okay, let's go back here. So if you want to view your releases, that's all of your, every time you do a successful Git push where the build succeeds, every time you do a configuration change, every time you do an add-on change, all of those create a new version of the slug file, and you can see all the releases with Heroku releases, and you can roll back to the previous or any release with Heroku rollback. Get through that array. So I'm going to do a $@each, and I'm going to give it data as the parameter, and then this takes a function with an index and an item parameter. So on each of the items that I get back, I now want to append them into the page using DOM manipulation in Jquery. But at first I need a place to put them. Let's go create a little UL here on the page called bars. Here we go. Okay, so I want to find that bars object in Jquery. I can find it with doing like a query for this bars by ID. That's the syntax for that. I'm going to say append a new list item into there, and I'm going to just say item.name. Okay, does that look good? Did I make any code errors? Pair programming, massive code, pair programming. Does it look okay?
It's correct.
Is it going to work? Okay, let's go back here and hit refresh. Hey, there we go. Cool, so that is now, when the page loads, calling the JavaScript in jQuery, making the GET request out to that JSON service, pulling JSON back, turning it into objects, iterating through it, adding them to the UL element on the page. So yeah, jQuery. Cool. Any questions about that? Yeah?
HTML escaping, or was that magic happening there?
HTML, oh, that doesn't happen. Yeah, so I posted this demo on my blog a while back, and of course everyone starts inserting the JavaScript scripts into this thing. I had to go like delete the database every 10 minutes. Yeah, so I believe that there is a play function that will cleanse the input for me, but that would be another line of code. So okay.
The HTML display.
Was that
the values from the database? When you take your field and show them the HTML, it's like that string adding is like an automatic escaping, and if that's the case, what do you have a different function if you want to put out raw HTML?
There is another function, yeah, if you want to put out raw HTML. Okay, other questions about that? Okay, so my application, it's very sexy, ready to go to the cloud, almost ready to go to the cloud. So we do need to configure this application to use the Postgres database rather than in-memory database. So to do that, it's pretty easy. I'm just going to say, for prod mode, that's what I'm going to run on Heroku, is I'm going to run this play app in prod mode. I'm going to say, set the database equal to, and now I can use that database URL environment variable there. That's because they have that built-in support for reading that format of database URL. But then I also need to set the JPA dialect there, the prod mode to Postgres dialect, and I need to set the DDL to update instead of create. Okay, so now it should be ready to go to Heroku. So let's go out here to, oh yeah, look at that, forgot to mention. I didn't restart the server at all, no rebuilding more files, redeploying, restarting Tomcat. This is why Play Framework it's way productive because you just keep reloading your browser. So, okay. So let's play it on Heroku. So we're going to do the git init, git add, I want to add everything. Let's see. Add app conf, don't want lib, I want public, test, and temp. I think that's good. Okay, now commit. There we go. And now we're going to do the Heroku create. We can create a fresh new application for this one on the Cedar stack. Ooh, I didn't want to have the temp directory. Well, maybe a little bit okay.
What about proc?
What?
What about the proc file?
Good question. So Heroku knows what a Play Framework application looks like. So we know how to start a Play application. We don't need a proc file. We just infer one. You can, of course, specify one on your own, but we don't need one. Evening Mountain. Did I get Evening Ocean and Evening Mountain?
Yeah.
That's cool. Okay.
Probably something wrong.
Okay, let's push this up to Heroku and hope that my temp name is okay. Any questions? Well, let's upload it. Yeah.
So it's interesting that you're actually pushing it out in sort of expanded mode because you can generate more files and stuff to play also. I guess with that you just bundle it with Jquery or something.
Yeah, great question. So Play Framework has a built-in Netty server, so it's NIO-based, really high performance. We can use that as the server on Heroku. That's totally fine. That's what I'm doing here. That's what I do for a lot of my applications. Play Framework does have the ability to create a Word file and deploy that Word file in a container. You can go that route if you want to. Then on Heroku, you have to bring your application server with you as well. So different ways to do it. totally up to you how you decide to do it.
You work on, you got 50 megabytes.
It would be how big? Bigger than 100 megabytes?
Because they dump it every,
Yeah. The Play 2 apps are very large. They're like 80 meg big, so yeah, Scala. Gotcha.
Without necessarily debating whether or not this is a good idea, is there any way to get Play to just look at the template file without going to the controller first?
No, you have to go through the controller. If you do want to go to a template, you can, of course, there's a public directory there that I didn't show that you would stuff just static files into, and then you can go to /public/whatever, and then you will just handle that request without going through your controller. But that wouldn't work for
The
templates.
site that I'm trying to build has some more or less static pages, except for let's put out a date and count down from a fixed date to say, 100-something days until.
Right.
And that's the only dynamic on the whole page.
Yeah.
So it's kind of open. Because otherwise, right now, a half dozen, public static renders, public static.
Right, yeah.
It just seems.
There may be an easier way to do that. I can talk to you afterwards.
Yes.
Okay, let's see. Are we up and running? Let's go check out the Evening Mountain. Our very exciting layout. Let's make sure it's all working. Yay! Okay, cool. So that's my layout running on top. Okay, any questions about that? Okay, got it. 10, 15 minutes left. I want to show some Scala stuff real quick, running Scala on Heroku. Any questions before I come to that? If you're interested in the Play 2 Scala stuff, I just posted a blog this morning that basically goes through what I just showed you, but with Play 2 and Scala. So if you're interested in that, I'm going to show another Scala thing, not Play 2 Scala. But if you're interested in Play 2 Scala, check out my blog. Okay, so let's go on to Scala stuff. So this one I'm not going to start from scratch. I'm just going to show you a little app here. So this one, really simple project. It's a Scala web application that uses Twitter Finagle. Finagle is a library for Twitter that actually builds on top of Netty. You'll see this common theme with most of the next generation Java or Scala-based web libraries. Anything that does HTTP anything now is being built on Netty. Netty has really become the standard for NIO-based HTTP routing. So Finagle, used by Twitter for massive scalability, huge throughput, which got them out of the fail whale Ruby on Rails stuff that they were on before. So Finagle, built on Netty, that's what I'm going to be using in this example. So the way that I in Scala, or the way that I've chosen to do it here, is I'm using the Scala build tool, SBT. So I have a project that, build that SBT. So this defines the metadata information about this project, and also defines Finagle as a dependency specification. So this is just the SBT format for defining my project information. So one other thing here. We need some convenient way when we start up an application on Heroku to set the class path. So the examples that I showed before with Jetty and with Play, setting the class path was kind of taken care of for us. We go this route, we would have this massive line that we would have to specify to set up our class path. So the way that I'm doing it in this case, just optionally, is I'm using this plugin, this SBT plugin from TypeSafe, the company behind Scala and Play Framework and all that good stuff, Akka. So they created an SBT plugin that will generate a script that will set up my class path based on my dependencies for me. So that's all that's doing. So then, what was that?
Based on the POM file,
based on the SBT build information. So the only dependency this application has is Finagle, but Finagle has its dependencies, Netty and other things. And so the start script plugin will actually read this dependency tree, and then once all the dependencies are pulled down, it'll know how to set up the class path based on the dependencies that were required from my application. Did that answer that question?
I'm lost in this.
Okay. SPT is a confusing beast, so I still don't really grok it. So let me show you the proc file real quick. So the proc file is just saying for the web process, call this start script that got generated from that SPT start script plugin, which is target/start. And then web is the name of my class that I want to start. So let's go check out my Scala code real quick. So that's in source, name, Scala, and then web.scala, which becomes my web application, my web class that I'm starting. So I've got all my imports for Finagle. Netty is sponsored by JBoss. That's where you see that port JBoss Netty up there. So let's see. So I've got an object web. So in Scala, an object is a singleton essentially, and so it's got a main method on it. So this is kind of like doing a static void main, right? So it's got a main method. It takes arguments possibly. It's also looking for that port environment variable because Heroku will tell us what port to run on. But if we don't have a port environment variable, it's just going to default to 8080. And then I create this server builder. I add a codec of HTTP, give it a name, tell it to bind to the right socket and port. And then I'm adding a new service into Finagle. So that's what that's doing. The new hello is then using this hello class. So class, I can create multiple instances of this. And it extends service with an HTTP request and an HTTP response. So this is one of the really cool things about the reason why people who need this massive scalability are going to NIO-based systems is that you'll see in this apply method down here, it takes an HTTP request, but it returns a future of an HTTP response. And what this allows me to do is actually, instead of returning the response, which would block an HTTP thread, make it synchronous, I can now with futures make it asynchronous, and because Netty is based on NIO, it can actually reallocate that HTTP thread while this thread is off doing something else. And then as soon as it needs to do the HTTP response, then Netty will say, hey, I need an HTTP thread back. It'll get one, and then send the response back to the client. So this is really the future of these highly scalable systems, is to do non-blocking all the way through, even all the way back to your data source. So there's some experimental work happening right now for MongoDB, where they're actually using Netty to be a MongoDB driver. So all the way back to your data, you can actually be asynchronous and non-blocking the whole way through your request processing pipeline. So really potential for really high scalability with this stuff.
So debugging is always fun, right?
What is that?
Debugging is always fun, right?
Debugging is always fun. Yes, whenever you get into asynchronous programming and multi-threaded programming, and we've had it pretty easy as web developers. Most of us haven't had to think about threads for a long time, you know. So it's getting fun again. Yeah, question.
So we also have this concept of broker nodes, right? And how are they used? Like if you use actors, so they automatically go into those broker nodes, or you use the framework, or you run Add-On jobs.
It's a really good question. So I think what you're asking is, on Heroku, I can have a bunch of nodes running. And with things like Akka 2.0, I can now distribute my actors across nodes. They can actually be remote actors. So you can use Zookeeper to actually coordinate your actors across a whole system of nodes. And it becomes this really fantastic way to scale to massive scalability, all in an actor-based model and all in a distributed model, right? Like this is the future of asynchronous actor-based processing. But Heroku today does not support Zookeeper as an orchestration layer on Heroku. It's something that we're definitely looking at and seeing, you know, if, when, how, all those sorts of things. But today, no, we don't do Zookeeper on Heroku. Yeah, so they are separate nodes. But the challenge is that you need your nodes to communicate in some way. Heroku nodes actually have no way to talk to each other. If Heroku nodes need to communicate to each other, they have to go through an external system. So we have an add-on for RabbitMQ, we have other messaging add-ons. So we would have to use a messaging bus in an external system as a way to orchestrate and communicate between nodes. And so theoretically, we could have Zookeeper running as an external service, or something like that that is orchestrating dynos and saying, hey, actors run here, you actors run there, doing all this sort of stuff. But we just have all
That doesn't actually work because basically just set up, they call some external data store to do something.
or listening on a rapid message queue or something like that. Yeah, good question.
So that's part of that answer, because what you just said, but I want to run that, so that I can do the not use job.
Yep.
That's not just yet.
So I think it's in beta. We have Hadoop. I think it's Hadoop as a add-on for Heroku. That would be the better place to do that sort of thing, rather than try to do that at the dyno layer. The dyno layer is more about processing web requests, processing worker requests, those sorts of things. But for like MapReduce types of jobs, you probably don't want to be in the dyno layer for that. You potentially could be. I haven't known anybody that's done that kind of stuff at the dyno layer, but it certainly is possible. Okay, I'm going to move on real quick. We're almost out of time. I want to just show you this running on Heroku real quick. Let me remove my .git directory. Let's do that up. Let's create a new Git directory and add in my proc file, my build.sbt, my project directory. Ooh, that's good. And my source directory. Okay, make sure that's okay. Okay, now git commit and git. Oh, no, we don't need to git. Let's do Heroku create on the Cedar stack. We get another evening one. This is going to be worry about a randomness here. Afternoon this time. All right. Good. Afternoon's done. Okay, so Heroku has support for SBT, so now when I do my git push Heroku master, we will receive the files, run the SBT build. We run the stage task on the SBT build, so that start script plugin actually binds to the stage task, so it'll generate that start script, that target/start, pull down all the dependencies, all that sort of thing. And SBT, for some reason, I think the ID underneath the covers takes forever to resolve dependencies. I don't know why, so this might take a minute. But while it's running, any other questions about anything? Yeah.
Well, I was going to ask, what would be the advantage of running Hadoop under Heroku versus Elastic MapReduce?
Good question. I have no idea. Yeah, I have not ever done any Hadoop. So you could run it on EC2 and feed the results into a Heroku application, and that would probably be a good way to do it. I don't know if you could do that all on Heroku dynos. Yeah.
Was Heroku profitable when it was bought by Salesforce?
Good question. I do not know. I just joined like 6 months ago, so after the acquisition. Yeah. Good question. Yeah.
So is there a Heroku CEO live in Seattle and the rest of the company is somewhere else?
No. Most of Heroku is in San Francisco. I'm in Denver, so I travel quite a bit for my job. But yeah, the Seattle connection, I don't know if we have a Seattle connection.
So LinkedIn today lists a Heroku CEO in Seattle area. So
Really? What is that? Oh, we just have one. Byron Sebastian was the CEO of Heroku, and is now the SVP at Salesforce.com over the platform. Okay, let's check out our afternoon stone, make sure that this Scala app is working on Heroku. And there we go, hello from Scala. Yay! Okay, other questions? Yeah.
Okay, Pet Clinic is a reasonably complete and sophisticated application, although I have no idea what it does because you wrote pick one line of code and it will generate.
Get through that array. So I'm going to do a $sign after each, and I'm going to give it data as a parameter, and then this takes a function with an index and an item parameter. So on each of the items that I get back, I now want to append them into the page using DOM manipulation in Jquery. But at first I need a place to put them. Let's go create a little UL here on the page called vars. Here we go. Okay, so I want to find that vars object in Jquery. I can find it with doing like a query for vars by ID. That's the syntax for that. I'm going to say append a new list item into there, and I'm going to just say item.name. Okay, does that look good? Did I make any code errors? Pair program, massive code, pair program. Does it look okay?
It's correct.
Is it going to work? Okay, let's go back here and hit refresh. Yay, there we go. Cool, so that is now, when the page loads, calling the JavaScript and jQuery, making the GET request out to that JSON service, pulling JSON back, turning it into objects, iterating through it, adding them to the UL element on the page. So yeah, jQuery. Cool. Any questions about that? Yeah?
HTML escaping, or is that magic happening there?
HTML, oh, that doesn't happen. Yeah, so I posted this demo on my blog a while back, and of course everyone starts inserting the JavaScript scripts into this thing. I had to go like delete the database every 10 minutes. Yeah, so I believe that there is a play function that will cleanse the input for me, but that would be another line of code. So okay.
HTML display.
Was that
the values from the database? When you take your field and show them the HTML, it's like that string adding is like an automatic escaping, and if that.
Yeah.
How many do you have any examples? Are all the other examples the more world you just showed us, or do you have anything?
Yeah, good question. So there is lots of different ones. So there's if you go to java.heroku app.com. So this app in itself is actually a play app. So this is a little more sophisticated. What this one does is, I mentioned earlier, it allows you to take one of these demos that I've showed or other applications. So there are ones that are more than Hello World. Some of these are just Hello World. But like you're going to see the Spring Reader one. There's one that has Web Solar, which is more interesting. You can see a live demo of it. There's one that is Scala plus Akka is this one that I forget, it's like indexing something. And so that one is definitely much more complete than a Hello World. But yeah, most of them are just the bare bones Hello World. But there are a few in there that are.
We have, for example, this e-commerce application.
What is it?
E-commerce, sell cupcakes on the web.
Oh, good question. I don't have one, but if you know of an open source one, let me know, and I can run it on Heroku and put it on this page for you.
So, Web Solar, is that Solar as in,
the indexing service. Yeah, so that's an add-on for Heroku. You can use Web Solar indexing service as an add-on. So that's just an example that shows how to use
Web Solar, so it'll index your own site, this site?
No, it's just indexing as a service. So I basically feed information into it, it creates an index, and then I have an API to get to that index. Yeah. So indexing as a service, I guess. Yeah.
Can you speak real quickly about the REST API that you just talked about? You referred to a few times.
Yeah.
Is it like,
yeah.
Is that like features for monitoring and things like that, or
Yeah, totally. So we do have some docs for it. doc.heroku.com, I think. So we do have some URL that docs out all the REST APIs to Heroku. The easiest way to understand what you can do and to do anything with those APIs for me is just to download the Heroku jar file. So on Heroku's GitHub, github.com/Heroku/Heroku.jar. This is the Java library that wraps those REST APIs. So if from a Java app you want to call the APIs, this is the way to go. So I would check that out. And email me, I can send you the link to the actual REST API documentation. Or you can probably find it in the search. Okay, one more question, and we got to grab
It's
it.
not a CDN plugin, so I can sort of modify the commands of JavaScript process and run through it.
Great question. So for Play Framework, there is a module called GreenScript that does some of that for you. It's the model that we're definitely evolving towards is I have my application server that's serving just JSON, and then I'm serving all my static content through a CDN. I think that's definitely the future of web applications. The tools that help us to get there, I think, are evolving right now. Play Framework has some. I'm working on an SPT plugin that will help to do that for Play 2 and Scala apps. I did a blog post on this architecture on using Blue Eyes and Scala as the JSON server and then jQuery on fine, put it all in CDN, whatever. So I think it's an evolving space. I think that this will be the architecture that we're all using in a few years for our applications. It just makes a lot of sense, but I think it's cool for evolving. So beyond play framework, don't know what exists in the Java world. There should be a Maven plugin for doing that. I haven't seen it. Okay, we got to get out of here, so we're going to have to wrap up. But I'll be around. We're going to have some beer. Where are we going?
Probably just down the street. There's a German place and there's an Irish place, so we got pretty good choices.
Okay.
So if people want to go for beers, have more questions, whatever, just stick around in the room and we'll head out in a few minutes.
Okay.
Thanks a lot, James.
Thank you.